4.7 million years. It's almost impossible to comprehend, isn't it? For context, 4.7 million years ago, our ancestors were barely walking upright. They hadn't discovered fire. They hadn't built a single shelter. They were just beginning. Now flip that timeline forward. Imagine humanity, us, trying to survive that same span of time into the future. Not just survive, but sustain life across millions of years of cosmic chaos, planetary shifts, and evolutionary pressure. Could we do it? Could present-day humans, or something descended from us, actually make it that far? Tonight, we're going to explore that question, and I promise you, the answers are stranger, more beautiful, and more terrifying than you might expect. Let's start with the uncomfortable truth. Right now, in the year 2025, we're not exactly in a stable position. Climate change is accelerating. Ice caps are melting, oceans are rising and acidifying. Biodiversity is collapsing at rates we haven't seen since the last mass extinction. We're burning through resources faster than the planet can regenerate them. Fresh water is becoming scarce, topsoil is eroding, and our population, nearly 8 billion people, is still climbing. So before we even think about 4.7 million years from now, we have to ask, can we survive the next 100? The answer, surprisingly, might be yes, but only if we fundamentally change how we live, how we think, and what we're willing to become. See, the challenges we face right now aren't just environmental, they're existential. They're forcing us to make a choice, adapt radically, or face extinction. And if we choose adaptation, well, that's where things get interesting. Because adaptation, on the timescale we're talking about, doesn't just mean planting more trees or building seawalls. It means transforming ourselves, technologically, biologically, philosophically, into something that can survive not just centuries, but millions of years. Let's imagine we make it through the next few centuries. We stabilize the climate, or at least learn to live with a hotter, wilder Earth. We develop sustainable systems. We stop the bleeding. What comes next? Technology. Not just as a tool, but as an extension of our very biology. Artificial intelligence will likely surpass human intelligence within this century, maybe sooner. But instead of fearing that, imagine we merge with it. Imagine humans with cognitive abilities enhanced by AI, able to process information at speeds we can't currently fathom, able to solve problems, environmental, social, cosmic, in real time. Genetic engineering will become routine. We're already experimenting with CRISPR, editing genes to cure diseases, but in 1,000 years, 10,000? We could be editing ourselves to survive extreme environments, high radiation, low gravity, toxic atmospheres. We could engineer humans who can hibernate for centuries during long space voyages, who can breathe different atmospheric compositions, who ages slower or not at all. And then there's space. Because here's the thing, Earth won't last forever. Even if we fix every environmental problem, even if we turn this planet into a paradise, the sun is slowly getting hotter. In about 1 billion years, maybe less, Earth will be uninhabitable. The oceans will boil away. The atmosphere will strip off into space. So if humanity wants to survive 4.7 million years, let alone billions, we have to become a multi-planetary species. And if you're enjoying this journey into deep time with me, if you want more explorations like this, more late-night drifts through science and speculation, go ahead and hit that subscribe button. It helps more than you know. All right, let's keep going. Planetary migration isn't just science fiction anymore. We've already identified thousands of exoplanets. Some are Earth-like. Some orbit in the habitable zones of their stars where liquid water could exist. Mars is the obvious first step. We could terraform it over centuries, thicken the atmosphere, warm the surface, introduce engineered microbes and plants. It won't be easy, but it's possible. Then there are the moons, Europa and Enceladus, icy worlds with liquid oceans beneath their surfaces. We could build colonies in those oceans, in subsurface habitats lit by fusion reactors, sustained by hydrothermal vents. And beyond our solar system, generation ships, massive vessels carrying thousands of humans on journeys lasting centuries, even millennia to distant star systems. But here's the question: who arrives at those distant worlds? Because over millions of years, the humans who leave Earth won't be the same as the ones who arrive. Which brings us to biology. 4.7 million years is a long time in evolutionary terms. For perspective, 4.7 million years ago, the lineage that would become humans was still shared with other great apes. We hadn't even split off yet. In that time, we went from tree-dwelling primates to builders of cities, inventors of language, and explorers of space. So what could we become in the next 4.7 million years? If we colonize Mars, humans there might evolve, or be engineered, to have larger lungs, denser bones to counteract lower gravity, skin that's more resistant to radiation. In ocean worlds like Europa, we might develop traits for aquatic life. Maybe not gills, biology doesn't work that fast, but cybernetic enhancements, biosuits that become permanent, integrated into our bodies over generations. And if we're traveling between stars for thousands of years, in the isolation of space, in artificial environments, human populations could diverge radically. Imagine different branches of humanity, each adapted to their own world. Some might no longer look recognizably human. They might communicate differently, think differently, be different. But here's the beautiful, eerie part. They'd still carry something from us, from today. A genetic thread, a cultural memory, a shared history traced back to this pale blue dot spinning in space. And maybe that's enough. Maybe human isn't about having 2 arms and 2 legs. Maybe it's about curiosity, the drive to explore, to ask questions, to reach for something beyond survival. Because 4.7 million years from now, if something descended from us is still out there, still wondering, still reaching, then, in a way, we made it. We survived. So let's zoom out one more time. 4.7 million years. On a cosmic scale, that's nothing. A blink. The universe is nearly 14 billion years old. Stars will keep burning for trillions of years. We've started to ask the big questions. Who are we? Why are we here? How do we survive? And maybe that's what makes us special. Not our intelligence, not our technology, but our awareness of time. Our ability to look forward and backward, to imagine futures and honor pasts, to care about what happens after we're gone. 4.7 million years from now, the beings that carry our legacy, whether biological, digital, or something we can't yet imagine, might not remember our names. They might not know what Earth looked like when it was green and blue. But they'll carry the spark we lit, the first fire, the first question, the first time someone looked up and wondered, what's out there? And in that wondering, we'll survive. Not just as a species, but as an idea. An idea that life, conscious, curious, stubborn life, can endure. So, Can present-day humans survive to sustain life 4.7 million years from now? Honestly, maybe not in the form we recognize. We'll change, we'll adapt, we'll become something new. But our essence, the drive to survive, to explore, to matter, that could endure. If we face the challenges ahead with courage, if we use our technology wisely, if we remember that we're not separate from nature, but part of it, if we choose hope over despair, then, yeah, we might just make it. Thanks for drifting through deep time with me tonight. Until next time, keep looking up.